But in 1925, when quantum physics came in, it says you must include the energy in the equation. Now the question is this. I have a cell, and I know the behavior of the cell is elicited by the receptors that read the signals. Here's this beautiful understanding, because this is what simplifies my understanding about how it all works, and then I applied it to my life, and it made such beautiful changes in my life. And it works like this. I used to clone human cells, and when I put them in the culture dishes, I'd observe their behavior and do things. And one of the things that's very interesting, if I put a cell in the culture dish when I started, and the cell is here, and I put food over here, when I start the experiment, I put the food over there and cells over here. When I come back a little later, where do you think the cell is? The cell moves toward the food, right? Okay. Experiment number 2. I put the cell over here at the start of the experiment, and I put toxin in over here. And I come back in a few minutes later, where's the cell going to be? Over here. Look, this is so beautiful, because here's the truth. At the level of the cells of which we are based, there's only 3 behaviors a cell can do, obvious behaviors that you can see. And here are the 3 behaviors. The cell can move toward a signal, the cell can move away from a signal, and the third one is actually a signal can be made in the environment, but the cell ignores it because it's not relevant. So that's actually 3 different movements: moving forwards, moving backwards, or not moving at all. Does that make sense? I mean, you can see it, right? So here's the issue. Then the behavior of the cell is actually divided into 2 kinds of behavior. When a signal is presented that the cell needs for its maintenance and its growth, the cell will always move toward the signal. When the cell is presented with a signal that threatens its life, then the cell will move away from the signal. So there's only 2 behaviors. What are they? Moving forward is growth, and moving backwards is protection. So the bottom line is this. Point. Now look at the logic, because this is the part that's like profound but simple. A cell moves forward for growth, moves backwards for protection. Can a cell move forwards and backwards at the same time? Yes or no? No. Point. Fundamental, profound nature of the point. The cells in your body are digital. When they receive signals that say growth, they will move toward things in growth. But if they're not receiving growth, then they will move backwards in protection. And the point about it is this. Then the cells in your body are going back and forth between growth and protection based on what? The perception of the environment. But since the cells are in the community, they're also the perception of the brain. So as you're thinking, what are you doing to the cells? You're giving them information about their environment. If you think that, oh my God, I can't make it through this lecture because the damn projector broke. Oh my God, what do you think my cells are going? Oh Bruce, they're hiding out. On the other hand, it's like, cool, we can make anything, we can do anything, we can survive. And what are the cells going to do? Well, they're not going to shirk backwards, they're going to move forwards in growth. Why is this relevant? Because the behavior is that clearly digitized, that it's one or the other. And the point is this, although you have 100,000 different gene programs minimum, I can take all the gene programs in your body and divide them into 2 groups. Those genes that provide for growth and reproduction. And let me explain what I mean by growth. Growth is not just from a baby to an adult. You are growing every day. Why? Because every day you're losing thousands, millions, trillions of cells a day. And if you don't replace those cells, what's going to happen to your body? You're going to experience disease and death. And so the bottom line is this. Then for you to survive on a day-to-day basis, just to keep level, you're growing all the time. And that's a requirement of the system. So the fact is this. Growth goes on, and it keeps you healthy and alive. And then the issue is this. Once you reach a certain age, then the genes, there are also genes for growth, but growth of the next generation. So the growth genes are for you or for the next generation. So those are growth genes, okay? On the other hand, growth, as I said, is only when the cells are moving forwards. But when cells are moving backwards, they exercise protection programs. So there's another set of genes in your body, or your cells, which are involved with your protection. But the point about it is this. A cell at any one time is either in growth or it's in protection, but it can't be in both. Now I got to ask you a simple question, and it's economics. Does it take energy to grow? Does it take energy to protect yourself? Well, then the point about it becomes very simple, because here's the point. When you find that you're in protection, you have to use energy. But the more protection you're in, the more energy you use. Well, where are you getting the energy from? You have a balance. You have like a checking account in your body of energy to run this body. And the more checks you write for protection, what happens to the balance? It gets less and less. And there's a point where so much protection is used that you actually now short growth processes. And this is true for like the nation right now. Right now, our budget has in excess of 50% of the U.S. budget is in protection. What does that mean? Well, all that money that's allocated for protection is not helping us grow or maintain the country in any way, because that's all put into armaments and whatever they are. And the issue is this applies to your own body. When you walk out on the street, when you wake up in the morning, you start to live, you're vacillating between growth and protection. And the issue about it is the more protection you require or you perceive you require, and that's the trick, the one that says you think you need protection, the more you put into that, the less growth you start to accommodate. And here's an interesting part. You could be so afraid, you can be scared to death. And that's the truth. The truth is this, that fear can be so great that you absolutely shut off growth so quickly that you actually die right at that moment. And the reality is, understand the balance of your health is related to the amount of energy expenditure you're putting into protection. So the bottom line, survival is actually equal to growth divided by protection. And now look at this. Turn on the news. Read the newspaper. Listen to the TV. What do you hear every day? More reasons to protect yourself. Well, the air's not good. The water's not good. The food's not good. These people are unsafe. Every time you turn around, what are you doing? You're walling yourself off more and more. Why? Because growth means to go forwards. What is protection? Go backwards or wall off the outside. We start to isolate when we start to become fear-bound. And as we become fear-bound, we shut down growth as a natural biological mechanism. But it's interesting. I have 50 trillion cells. Each cell can be in growth or protection. But my whole body doesn't have to be in growth and protection, so I can have a range. My body can be in, so many cells are in growth, so many in protection, so I can have a percent. So when I look at the human system, I also recognize that growth and protection is a variable, okay? And here's the interesting part about it. When I'm growing, which biological systems in my body am I using for growth? And the answer is all the organs in here called the viscera. The heart, the lungs, the digestive system, the liver and pancreas, and all these things. These are for growth. When I protect myself, which system do I use? Get out of here, I'll hit you with my lung. No, that's probably not what it is. Okay? The point is, when you're in protection, what physiological systems do you use for protection? Muscles and bones. And the interesting thing is, there's a switch in your body that switches from either the viscera or to the muscles and bones. Remember that thing we call fight or flight? Remember that adrenal system? The adrenal system is a master switch that switches between what? The two systems. The switch says, if I start to get into fight or flight, what am I going to use? Muscles and bones. Well, I shut down my viscera in the process. And that way, I have all my energy allocated to get ready to run. If I need to run away from a lion, I'm not going to start processing digestion at lunch. Why? Well, that energy might be the exact energy that it took me to get the last step so my foot doesn't get caught in the lion's mouth. So the system is intelligent. It says, when you're under threat, it will allocate the energy to where the threats are. It shuts off the visceral system. So the bottom line is simply this. In growth, the visceral system commands the somatic system. It works like this. In growth, I need water. So my body says I need water. Well, how do I get to the water? Oh, well, I move to the water. So how do I do that? Through my skeletal system. Well, who directs it? The viscera says I need water, so the skeletal system responds to the viscera's request. So the viscera administers to the need, the skeletal system administers to the viscera's need. But here's the interesting thing. My viscera says, Bruce, you need some water. So I say, okay, let's go get some water. So I start to go get some water, and right away, there's that lion right in front of me. And the fact is this, at the moment I see the lion, well, what do you think I'm going to do?